Hi everyone, welcome to CJ Research and Consultancy, where we break down complex statistical concepts into easy to understand tutorials. Before we dive into today's topic, make sure to subscribe to this channel and hit the notification bell so that you don't miss out on any of our upcoming videos on data analysis and statistics. Your support helps us create more valuable content for you. I am also excited to let you know that a comprehensive course on statistical analysis is currently going on. In this course, we are going to cover everything from the basic of statistics to advanced techniques in SPSS, R, and Python, and even integrating AI tools like ChatGPT into research. If you're interested in taking your research or analytical skills to the next level, feel free to reach out to me via the email address provided in the description below. Seats are limited, so don't wait too long. Now, let us get started to what we have today. So today we're going to look at how to perform a paired sample t-test in SPSS. Before we continue, what is a paired sample t-test? So a paired sample t-test is also known as a dependent t-test. It is a statistical test used to compare the means of two related groups. These groups could represent measurements taken, such as measurement taken on the same individuals at different time, maybe before and after, or under two different conditions. For example, performance with two different methods, or any scenario where the measurements are naturally paired. The goal is to determine whether there is a statistical difference between the means of this paired observation. So when do we use a pair sample t-test? So we make use of the pair sample t-test when the two groups are related, and also when our data is continuous, and when we want to compare the mean of the main difference for the different conditions. What are the assumptions of paired sample t-test? So 1, the observations would be paired. 2, the data will be continuous. And 3, normality of the difference. So if these assumptions are met, we can now proceed to a paired sample t-test. Otherwise, we would use a non-parametric alternative. So now this is our data set. This is a data set for weight of before and after. So under your variable view, since we are making use of continuous variables, this weight before and weight after under types will be numeric. So every other thing will be left the way it is. So we'll go to data view. From data view, we would now proceed to analyzing our data. So we go to analyze, go to compare means. Under compare means, we go to paired samples t-test. All right, so now for the paired sample t-test, you would see that you will see the columns here for our weight before and our weight after. So for this, I will take it to variable 1. So now I'll move it to variable 1, and this for weight after, I would move it to variable 2. Now let's go to option and see what we have there. All right, everything is checked here. So now let us run the analysis. So this is our results. We have the paired sample statistics, we have the paired samples correlation, we have the paired samples test. So for the paired sample test, we are having the means of weight before, weight after, the number of observations, 300, the standard deviation, and standard error mean. Now let's quickly go to the paired samples correlation. For the paired sample correlation, we are having a correlation of 0.982 and is a significant p-value of 0.000, which is significant. So for the correlation of 0.982, this indicates a very strong positive relationship between the weight before and weight after, and this relationship is significant. All right, now let's go to the paired sample t-test. This paired sample test we are having for weight before and weight after. We're having their mean, standard deviation, standard error, their confidence interval, their test statistics, t-statistics, and the degree of freedom, then finally the p-value. So for their mean difference is 2.95702. So this is the difference between the means of the weight before and weight after, and it is approximately 2.96 kg. So this is indicating a weight reduction. Now for the standard deviation is 1.93234. So the variation in the difference, this is the variation in the difference between the paired observation. Now the standard error here is the standard deviation of mean difference for our standard error. So we have our confidence interval. So let's go to the t statistics. The t statistics here is 26.631 rather, and that is the t statistics, and it measures the size of the difference relative to the variation in the data sample. And this is the degree of freedom of 299. Then finally we go to the p-value. So for the p-value here is less than 0.05, and which is telling us that the weight before and weight after are significantly different. So in conclusion, we can conclude that the paired t-test result showed a statistical significant decrease in the weight after intervention, and the strong correlation indicates consistency in the data. This suggests that the intervention or treatment applied had a significant impact on weight reduction. So this is how we perform and also interpret a paired sample t-test in SPSS. Alright, so there we have it. If you find this video helpful, please give a thumbs up, share it with your friends, and don't forget to subscribe for more tutorials on statistics and data analysis. Also, don't forget to check out our ongoing statistical analysis course if you're looking to deepen your knowledge in this area. You can contact me through the email provided in the description for more details. Thank you for watching. I'll see you in the next video.